Hi there! So in this video I'm going to have a go at machining the standard for the Stuart 10V. So first of all, the casting needs to be tidied up. There's some quite large lugs on the feet, so I'll remove those with the bench grinder, and I'll tidy the rest up with a hand file. Well, that's looking a bit tidier. So I've decided to use a bit of this wet and dry just to clean the top face up. Now then, I've been doing some maths here, so the overall height I've measured to be 2.768 of an inch. So the overall height is 2.768 and the target is 2 11/16, which is 2.687. So overall I need to take 81 thou off. So that's in total, whatever I take off here and here needs to add up to 81 thou. Now this top flange here is round about, I mean it varies quite a lot, but it's round about 0.1470 of an inch, and the target needs to be 3/32, so that's 0.0940. So that actually means off the top I need to take off 53 thou. So therefore the amount to come off the bottom feet is 81 thou minus the 53, which is equal to 28. So I need to take 28 off here. Now I've debated long and hard as to how to approach this, and first of all I thought I might put it on the lathe, put that in the 3-jaw chuck and have a go at machining these feet. But I've decided I'm going to use the mini mill. Well, this is my setup and it's pretty rock solid, and I think it's my lucky day. I've got a DRO on the Z axis, and that reads 0, and if I move the Y axis in and check that height, it's 0 as well. So you know, that's spot on. So my target on here is to take 28 thou off these feet. So this is my setup for milling the top, and I must say that feels absolutely rock solid. So there's 53 thou to come off this. Well, my target height was 2.687 and it's actually 2.6885, so I'm happy with that. So now I need to drill out the centre to 5/8 of an inch in diameter. Now this is the first time I've used this boring head, so it should be quite interesting. And I've lined it up so it's just touching right around the edge, and then I've moved it out 5 thou. So I'm aiming for 0.625 of an inch. It's currently 0.589, so that's 136 thou I need to go. Divide that by 2 is 68 thou. So like I say, I'll cut in 5 thou increments initially, and I might up it to 10, and I'll keep track, and then I'll check my measurements, and hopefully we can get to the 5/8. Well, that was quite interesting. That looks pretty good. So I'll take it in 5 thou increments, and I'll get back to you with the result. Now I'm aiming for 0.625, and I've actually got 0.62, so I'm 5 thou under at the moment. Now it's not critical dimension this, because you make the crosshead to fit, but it'd be nice to be close. So what I'm going to do is I'm going to do a finishing cut of 2 thou. Now when I'm adjusting this, I can do these screws here, and then move this anti-clockwise to bring the cutter this way. So I'm just looking for 2 thou, and I'll lock again. When I make the cut, I go nice and slowly. When I get to the bottom, I turn the mill off and then just withdraw the tool, not spinning, and I think that gives a better finish. Looking good. Well, I'm very happy with the finish inside, and the diameter's pretty much spot on. Looks good from each of the sides, but unfortunately when I looked at the bottom, the hole isn't symmetrical, so I don't know what's caused that. But anyway, I'll press on and hopefully it won't have an impact on the overall engine. Fingers crossed. Well, this is a bit of a brain teaser, to be honest. I've put a piece of aluminium bar through the hole, and as you can see, the bar is exactly perpendicular to the flange. And I've also measured the feet, and the feet are exactly parallel with the flange as well. So all the machining has worked out right, but obviously when you look at the underside, the hole is to one side of the casting, not by a lot, but it is out, and I can only assume that the surface of the flange was out by a few thou to one side. It's not obvious when you look at it, or indeed when you measure it. So hopefully I'll be okay going forward, and I think I can make any adjustments when I connect the standard to the sole plate. Okay, so now I'm going to drill the 5 holes around the flange. Now I've already lined up the rotary table using this 2 Morse taper device that I use, and now I need to centre the standard on the table. I've locked the X and Y axis down, and I've modified these clamps and milled a hole at an angle there, so that will fit over that bit there. So if I put the clamp in, put this underneath at this side, I can then bring the 2 Morse taper down to centre the standard on the table, and all I need to do now is to screw these down. So now what I need to do is to move the table that way by moving the y-axis. Now I think they term it the PCD of the holes is 1 1/8 of an inch. So that I think means the overall sort of diameter. So if you're to drill a circle around here where you're going to drill the holes, the diameter of that circle is 1 1/8 of an inch. So that equates to, from a radius point of view, 1 1/8 divided by 2. If you multiply it by 25.4, that gives you 14.29 millimeters. So I need to move the y-axis that way 14.29 millimeters. 2, 4, 6, 8, 10, 12, 14.29, and I'll lock that. Okay, so this is take 2. I really nearly messed up here. I thought that the first hole needed to be drilled above the centre of one of the legs, but it isn't. It's got to be drilled at 90 degrees to the 2 legs. So what I've done is I've just put this ruler alongside the legs, and then eyeballed the edge to make sure it's running parallel with the table, and likewise on this side as a double check. So I'm happy that the legs are in line with the table. Now there are 5 holes to be drilled, so 360 degrees divided by 5 is 72 degrees. Now the dial on the table turns 4 degrees with a full turn, so 72 degrees divided by 4 is 18 turns. So I'm going to make a little dimple here just to make a mark. Then I'm going to unlock the table. then I'm going to go 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Lock the table. Make a dimple. And keep on going round until I've done 5 dimples. Well, can you believe it? I miscounted the turns on my first hole. So I've gone round again. Now, to double check this, a 5-hole PCD, I googled this, is equal to the distance between the holes multiplied by 1.7012. So the 5-hole PCD here is 1.125 of an inch. So if we divide that by 1.7012, I get 0.6613. So that is the distance between the holes. So I'm going to double check that with my caliper. So I've set it at 0.6610. And checking these holes, they are spot on. So I'm happy now that I've got all my calculations right. So I'll now carry on and I'll do the centre drilling, and then I'll drill to 7BA clear, which I think is 2.6mm diameter. Well, the 5 holes around the flange eventually worked out okay. So I've just marked up the 4 holes for the feet, and I've just eyeballed that, and I'll centre drill each one and then drill 2.6mm, which is 7BA clear. Well, that certainly turned out to be eventful, and I'm a little bit disappointed in the fact that the way this hole isn't dead centre with this bit of the casting. And I can only think that it's the flange. When I use the flange as this reference surface, I think we call it, so all the other cuts are based upon that. I think it was just slightly off on that plane. And to be honest, if I was to do it again, I wouldn't know how to check that was, you know, at the correct sort of angle. But anyway, hopefully we'll be okay. And I managed to avoid a total disaster. When I started drilling these 5 holes, I actually thought the first hole should be in line with that, and I did do a centre drill there. I didn't go right through, fortunately, and it was at that point I realised that the first drill hole should be there. So anyway, it seemed to work out okay in the end. But if anybody's any help and advice, I'd really appreciate it. I think one of the things that doesn't help at the moment is it's getting quite cold in this garage, and jiggling around with the camera and making sure my measurements are right can be a little bit tasking for somebody like me. But anyway, I hope you like the result, and I hope to see you later.